All right, guys, let's take a look at number 5. This is from determinants and areas of polygons. This is the formula we'll be using for it. And we have 6 vertices right here. 6 vertices means we're going to have 4 triangles. All right, so we're going to need to get the area for triangle 1, triangle 2, triangle 3, and triangle 4. If we come back here, because I started with this vertex right here, every single triangle is going to have this point. And that point is 8, 6. So 8, 6 here, 8, 6 here, 8, 6 here, and 8, 6 here. All right, what else does 1 have? So 1 has 8, 6. It also has 13, 2, and negative 7, negative 6. What about triangle 2? That has negative 7, negative 6. And it also has negative 10, 2. Triangle 3 has negative 10, 2. And it also has negative 9, 8. So triangle 4 is going to have negative 9, 8, and also negative 5, 10. So negative 9, 8, negative 5, 10. We're going to complete our builds. We're going to do it really quickly. So just 1, 1, 1, and then repeat the first 2 columns. So 1, 1, 1, and we repeat the first 2 columns. 1, 1, 1, and we repeat the first 2 columns, guys. Repeat the first 2 columns. 1, 1, 1, and then we repeat the first 2 columns. All right, start determinant. Now we're going to do horizontal multiplication. I'm sorry, diagonal multiplication. Geez, horizontal. Where's my head at right now? It's so late. Hope you guys are getting some sleep. Okay, let's get the mind refocused right there. So 8 times 2 times 1 is 16. 6 times 1 times negative 7 is negative 42. 1 times 13 times negative 6 is negative 78. So negative 42 and 16 is negative 26. So that gives us negative 98, negative 104. All right. Now, let's see what happens when we go from right to left. So we have 13 times 6 times 1, 78. We have 8 times 1 times negative 6. That's negative 48. And then we have 1 times 2 times negative 7. It's negative 14. So 78 minus 48 is 30. 30 minus 14 is 16. So negative 104 minus 16 is negative 120. So our area is 1/2 times the absolute value of our determinant. So we have 120 over 2, or 60. Now we need 4 of these. Keep in mind, right? We need 4 of these things. So we're going to go into triangle 2. I want to get the determinant there. So 8 times negative 6 times 1 is negative 48. 6 times 1 times negative 10, negative 60. Then we have 1 times negative 7 times 2, negative 14. So 60, 110, 118, negative 122. We go from right to left. So we have 6 times negative 7 times 1, negative 42. We have 8 times 1 times 2, positive 16. And then we have 1 times negative 6 times negative 10. We have 60. So 76 minus 42 is 34. So negative 122 minus 34. Area equals 1/2 times the absolute value of negative 156. So that is half of 156. So we have something we can break up, right? So half of 6 is 3, half of 50 is 25, half of 100 is 50. So that gives us area 78. So we have 60 and 78. And we come to 3. So as you go across, 8 times 2 times 1, 16. 6 times 1 times negative 9 is negative 54. Then we have 1 times 10 times negative 8, negative 80. So we have, what is this? Negative 134 plus 16, negative 118. And going from right to left, 6 times negative 10 times 1, come on, negative 60, there we go. 8 times 1 times 8, 64. And then 1 times 2 times negative 9, negative 18. So 64 minus 60 is 4. 4 minus 18 is negative 14. So negative 118 minus negative 14. So that gives us negative 104. Area is 1/2 times the absolute value of our determinant. So that's going to be half of 104, which is 52. Now we come here to this last one. And when we come over here, we see 8 times 8 times 1, that's 64. We see 6 times 1 times negative 5, which is negative 30. And we see 1 times negative 9 times 10, which is negative 90. All right, so we have 34 minus 90. So that is going to be, what, negative 56. Now we go back from right to left. So 6 times negative 9 times 1, that's negative 54. There we go. 8 times 1 times 10, it's 80. And we have 1 times 8 times negative 5. So that's negative 40. So that is negative 94 and 80, that's negative 14. So negative 56 minus negative 14, so that's going to be negative 42. So A equals half of the absolute value of our determinant, which is half of 42, which is 21. So we come back up here. So 8, 9, 10, 11. Carry the 1 right here. So 13, 18, 20, 21. Or you could say, right, so 138, 180, 190, 211. So now this 211 has units. It's very generic. It's literally 211 square units. So there you have it, guys. We have an example problem, and then we had 5 additional problems right here for determinants and areas of polygons. You had to use this formula, and you had to understand what this capital X was, and we saw that working through these 6 problems, that capital X was a matrix that we then expanded to get our determinant. All right, hope you guys enjoy these videos. The next one I'll put up will be 463.